Hello, my name is Victor Bosa, and the product owner of this project is Dr. Masoud Sadhadi. And in this video, I'm going to talk about the random forest algorithm for MQL5. What's a random forest algorithm? It's a set of decision trees that vote on a possible final decision. And what's a decision tree? It's a data structure that uses data mining techniques to, based on history data, predict a possible outcome. Let's take a look now at the algorithm itself. The random forest is already built in the math algebra library in the MQL5 standard library. Then what we're gonna do is that we're gonna use this implementation with some agents so we can take advantage of the random forest to do some predictions. In the constructor, we're gonna initialize all the variables that we have in the random forest algorithm. This is the constructor for our agent class. In the get RDF structure is where we actually load the random forest structure that we already saved. So the first thing that we asked is if we are in the optimization mode. If we are, then we try to get the previous errors. If there are no such previous errors, then we create a new file for errors. Now, what we're always gonna want to do is that we're gonna try to load the model itself, and then with this model, we're gonna try to do some traits. In the learn method, we ask if we are in optimization mode. If we are, then we are going to attempt to write the learned model to a file so we can use it later. Finally, we have the renovate policy and renovate reward methods. The renovate policy method is gonna be called every time we actually perform a sell or buy operation, and we're gonna keep track of the trading signals that we generate. For the renovate reward, on the other hand, it's only gonna be used when the wrong the wrong signal is issued. So if the random forest gives us bad data or bad prediction, let's say it tells us to buy and we buy and we don't make profit, then we're gonna punish it. That's the way we tell it to forget bad data and only conserve good data. We're also gonna have a collection of agents. In this case, it's gonna be a class random forest agent collection. In this class, we're gonna keep a set of agents, and each agent is gonna have a random forest. This way, we can have multiple random forests working for us. In the constructor, we're gonna initialize the agents, and as you can see, we're gonna have a learn all method that is gonna be a wrap method to call agent learn for each agent. We're also gonna have a method to set up agents. As you can see, it sets up all the agents attributes, right? We're also gonna have a wrapper for renovate policies. Let's call in renovate policies for each agent. The same with renovate reward. We call in renovate reward for each agent as well. And for trading signal, generate trade signal. Then here what we're gonna do is that we're gonna get all the trade signals for all the agents, and then we're gonna average them. The next step after creating the algorithm is to somehow take advantage of the algorithm by telling an expert advisor whether to buy or sell to make profit. The first test that I ran was with this expert advisor that is not using any signal. It's just an expert advisor using directly the algorithm, right? So this expert advisor works very well, and I've tested it several times. I've trained it several times, and as we can see, it most of the times generates profit. So the way this algorithm learns is by selecting find optimal parameters, and then we configure these three first elements, and then we run the optimizer, right? So playing around with those parameters, we can get different results. And then the optimizer runs. It takes a long time depending on the passes that we select, number of passes. And once it's done, we can close the MetaQuotes, MetaTrader, open it again, and run the algorithm. And most of the times we're gonna see an enhancement. Since the main goal is to make full usage of the MQL5 standard library, we should make all of our algorithms, turn them into signals, and if possible indicators that get attached to signals. So I try to make this algorithm an indicator, and then I connected it to a signal, and that signal to an expert advisor, and something in the connection was not correct, and it was very hard to debug to find the problem. So I decided to directly turn this algorithm into a signal, and then with this signal tell the advisor whether it's a good time to buy or sell. And here is the latest version. You can run it, and then let's run it in the, we can run it here. And then as we can see, we make some profit, right? So the issue is that running the optimizer is still in development. I will probably come back with an update as soon as the optimizer works properly with this signal. Let's take a look at the signal I created for the random forest algorithm. This is the descriptor for the signal, which is gonna let us use some parameters as input. These are the inputs for the signal, which are the same inputs we have for the agents. And these are all the methods that we're gonna have in the signal. In the constructor, we're gonna initialize all the parameters and the agents. And we're only gonna have one pattern in this case, so it's gonna have 100% significance. For long condition, we're only gonna perform if it's a new bar. If we got a new bar, then we're gonna try to find for a long condition, and what we're gonna do is we're gonna get the signal, and then we're gonna do some comparison. We have an inner threshold, and we're gonna compare the signal with a magic number and a threshold. And this is how we get the long condition. Similarly, with the short condition, we're gonna have a signal, and we're gonna compare it, and then depending on the comparison, we're gonna return the pattern or not. We're also gonna have a learn function that is gonna call the agent collection learn all, and this is our signal. It's a simple signal compared to the complex algorithm, and it's working. It only needs to it only needs to be implemented for optimization, and it should be good to go. Here we have the expert advisor generated using the random forest signal. So these are all the parameters for the expert advisor, and this is the random signal filter that we're gonna use for our signal. This is all generated by the expert advisor, and all we have to add in reality is to actually call the constructor in here. Instead of how it comes inside the onInit, we're gonna call it outside, because we're gonna pass some parameters. I'm gonna do this the first thing, and we're also gonna add the method on tester, and this is what needs to be enhanced, and which is the option optimizer. When the option optimizer is running, then the algorithm is gonna learn. Thank you so much for watching this video about random forest algorithm, signal, and expert advisor. My name is Victor Bosa. Here you have my contact information, and the product owner of this project is Dr. Masood Sadhadi. Thank you so much for watching.